All right, so again, we're going to do today what is called the ambiguous case and a little bit of law of cosines. You need to make sure that your calculator is in degrees, or else everything you do today will be wrong. Okay, so it's very, very important. And the calculators in the back of the room go back and forth between radians and degrees all day because my algebra 2s are graphing in radians right now and you guys are doing degrees. So please be aware if you borrow a calculator that it is not in radians, okay? I would hate to see you get everything wrong because of that. And yes, it happens. Okay, so right on over to your notebooks and we are going to do again what is called the ambiguous case. All right, so right on over and find a nice clean sheet to start yourself. And ambiguous case. So section 5.4 is what we call the ambiguous case. This refers to how many triangles are possible. So ambiguous case. Okay, so sometimes you're going to see today that you have 2 triangles possible or 1, and sometimes there is not a triangle possible at all, which you saw last Thursday. So this refers to the possible number of triangles. Again, it can be 0, it can be 1, and 2 at the most. You're going to use log signs to figure out how many are possible. Okay, so here's the first example. It's a big one, nothing. So we're going to determine, I'm going to say determine the number of possible solutions. Determine number of possible solutions. Again, it could be 0, 1, or 2. And I'm going to say then solve each triangle. So solve all the way through. When you solve a triangle, you are going to need the 3 angles and the 3 corresponding sides. Okay, so here's your information. I am going to give you that little b, which is the side length, is equal to 15. And little c is going to be equal to 13. And angle C, capital, is equal to 50 degrees. Remember, we are working with non-right triangles. So the first thing you want to do is sketch this and figure out where a good place to start would be. So it's going to start just like what we did on Thursday. So here's a triangle, and your vertices are denoted with capital letters. I'm going to go A, B, C. So A, B, and C. And we know that little b is 15. So where does little b go? Across from capital B. So that goes here. Again, pay attention to your notation, please. And then little c is across from capital C. And angle C is equal to 50 degrees. So you've already made use of this formula. The formula you are going to use when you have 2 copies of the same letter, and then I have B and I'm looking for capital B, is the law of sines. You're going to look right on your formula sheet. And where we really want to start this question is to find angle B right up here. I'm going to keep this nice and organized, and we need to start by finding angle B. So capital B. So I'm going to do B over sine of B must be equal to C over sine of C. And when you set up this formula, you should know 3 out of 4 of these items. Otherwise, you get stuck. Little b, what do I plug in for little b? 15. Good. Do we know sine of b? No. Over the sine of b. And that is equal to little c. We must know that from somewhere. 13. And this is divided by sine of 50. You want your answers to be as accurate as possible. You're not going to type anything into the calculator until the very end. So what I do is cross multiply. So I'm going to get 15 multiplied by the sine of 50 equal to 13 times the sine of b. Again, no calculator yet. Divide by 13. Divide by 13. And what remains is the sine of b is going to be equal to a large decimal. So now go ahead and grab your calculator. You want to type in 15 sine 50 enter. Divide by 15 enter. Everyone get a decimal? Okay, do not round it. If you want it written on your paper, it is 0.88 38974344. And then what do you have to do in the calculator to get the angle now? Second, good. So you're going to go second sine of that value and use your calculator, just hit the up key. So that goes right there. So second sine of that decimal, and I'm going to round accordingly. So the question rounded to the nearest whole number. Let's do the same thing. Everyone get 62 degrees. Perfect. So angle B is equal to 62 degrees. Okay. Now what you do is you set up two possible cases. We always want to check the maximum possible. We already know this time is possible because we haven't gotten an error. So now I'm going to come over here and I'm going to say case 1, case 2. So I'm testing case 1 and then case 2. What you're going to do is take the angle that the problem gave you and write it twice. That one doesn't change. So C is 50 degrees for both possible triangles. So C is 50, C is 50. Now I'm going to grab the one I just found, which was angle B. So angle B is 62 degrees. What do angles in a triangle have to add up to? 180, good. So you're going to go A is equal to 180 minus 50 minus 62, which is, oh, you guys are fast, thank you, 68. So is this triangle possible? Yeah, it doesn't exceed 180. That was good so far. Now the next case, here's where this comes from. You're working with the law of sine. If you think back, sine was positive where? Quadrant 1 and 2. We already had our answer for quadrant 1. Quadrant 2, how do I put this in the second quadrant? What was the rule? 180 minus 62, right? Which is equal to 118. Okay. So far, is this one okay? Do we have enough left over for angle A? We do. So angle A, I'm going to grab the calculator and go 180 minus 118 minus 50, which means angle A is 12 degrees. So we have two triangles possible here, and we're going to have to finish it. So two triangles possible. There's quadrant 1 and quadrant 2. All right, so the last part we have to do is solve the triangles. We already know all three angles. So that's taken care of. We already know little b and little c. What do we need for case 1 still? Little a. Yep. So for case 1, I need to find little a, and then I'm done with that one. And at this point, you have so much information that you can set this up two different ways. I know I have to do A though. So A over sine of A. Again, is a general rule of thumb. It's advisable that you not go off your own work. So I'm going to use the C's again. So C over sine of C. So I'm going to go A over the sine of 68 degrees must be equal to 13 over the sine of 50. And this all depends on how much work you want to show on your paper. You don't have to show the decimals. You can just use your calculator. But this is going to be 13 sine 68 equal to A sine 50. You do not have to hit the second key this time. So divide by sine of 50, divide by sine of 50. And answer, I'm going to round this the same way the question did. Whole number. You guys get 16? So little a for triangle 1 is 16. Perfect. Okay. Now I just have to do it one more time. Now I'm going to go over here. And really the only thing that changes is just the angle. So instead of using 68 degrees, I'm going to use 12. So I'll skip some steps. Let's go right here. I'm going to go A over sine of 12 must be equal to 13 over sine of 50. And again, it's just calculator work. 13 sine of 12 equals A sine of 50. And then divide by sine of 50. And then this one's all set as well. So 2 triangles possible. So divide by sine of 50. Anyone have it yet? Rounds up to 4. Thank you. So A is equal to 4. Okay. How's that one on the way through? Not bad? Yeah, it's not bad. It's just, and again, some of this work here, if you can consolidate that, that's okay too. But it's just law of sines multiple times. Anytime you have that letter that repeats. Okay, so over to another one, similar but much shorter. It's pretty much as long as those get. All right, I'm going to give you number 2. And if you remember a concept from geometry, this one's going to be really fast. So triangle EFG instead. And I'm going to give you little f equal to 21. And little e equal to 21. And angle E equal to 75 degrees. I want you to find all possible values for angle F. So find all possible values for angle F. And state how many triangles possible. So, and state how many possible triangles, 0, 1, or 2. Abbreviate anything you would like. Okay, so I'm going to sketch another triangle and label this one EFG. So we're going to go EFG, where little f is 21 and little e is 21 and angle E is 75. So if you were going to use law of sines, what angle would you start with? Angle F. Do you have to use law of sines? No. What kind of triangle is this? Isosceles, yep. So this is your isosceles triangle. I'm going to abbreviate, which means that you have 2 congruent angles. So I would know here the angle F is equal to 75. So again, it's a cross. So I'm going to set up case 1, case 2. and just figure out what's possible here. Again, you want to start with the angle the question gave you twice. So that was angle E. So E is 75. E is 75. Now go to the one we just found. We just found that angle F was 75. So do we have enough left over for G? Yeah, how much? Good. So case one is possible. So the first possible for angle F, we could definitely have 75 degrees. And then let's look at this one. So now I go over to case two. Case two stems from the fact that you have a second quadrant triangle as well. So again, you want to think back to this. So I'm going to do the angle F is equal to 180 minus 75, which means it could potentially be 105. But is this triangle actually going to work? No, not possible. There is not enough left over for angle G. Okay. So this would be an answer in which one triangle is possible. Okay. How's that one? Pretty good? All right, great. So here's one more of your ambiguous case. And you're just testing all those different possibilities. So I'm going to say triangle UVW. So triangle UVW. And I want to give you little v equal to 8.1 and little u equal to 7.6 and angle u equal to 68 degrees. Find all possible values of angle V. I'm not going to have you solve this one all the way out though. I'm abbreviating. Find all possible values of angle V. And we'll just say number of triangles possible. And number of triangles possible. Okay, so again, start with a picture so you can visualize this. So I have UVW. U, and then V, and then W, where little v is equal to 8.1. Little u is equal to 7.6. Capital U is 68. Okay. Remember to use law of sines. One of your letters, you have to have both the angle and the side. So do you? Yes. What can I start this one with? What angle can I find? Angle V. Good. So I'm immediately going to start by finding angle V. And again, when you have the two letters that match right here, this is always law of sines. Because we're going to change up your scenario, the next problem, and do a law of cosines. So I go u over sine of u is equal to little v over sine of v, and you just plug in 7.6 over the sine of 68 is equal to 8.1 over the sine of v. Do we need to use the second key for this problem? Yes, because the angle is unknown. I'm going to cross multiply, getting 8.1 sine of 68 equal to 7.6 sine of v. Divide that over and do second sine in your calculator. All right, so I have 8.1 sine of 68 divided by 7.6 gives me an angle of 81. Any problems there? Good, it's just calculator work. But you want to make sure you can actually do it. Next, I test my cases. So I'm going to say possible case 1 and 2. So case 1, case 2. So I'm going to start with the angle I know, and I'm going to write that one twice. So angle U is 68 and 68. Next, I found angle V is equal to 81. Is there enough left over for W? There should be. 180 minus 68 minus 81 is 31. So good to go on that side. Next, angle V. Second quadrant means 180 minus 81, which is equal to 99. And is there enough left over for W? I think there's a little bit. What is it, 13? Thank you. Small angle, but it's possible, so you're good. So possible angles for V would be 81 and 99. And how many triangles possible overall would be 2. So 2 triangles possible. Okay. How does everyone feel with law of sines? Pretty good? Okay. So I'm going to do one problem that makes use of what we call the law of cosines, so that you can immediately see right now why it's different. So when you use law of sines, you see how you have 2 of the u's? Okay. Law of cosines, you're not going to have that anymore. So just one of these. And this is, again, also right on your formula sheet. So this is 5.5, because then you can start those. So this is what we call law of cosines. I'm not going to finish these today. But what we're also going to add on tomorrow is what is referred to as Hero's formula, which just pertains to area of a non-right triangle. Okay, so law of cosines is right on your formula sheet. And it's going to look very similar to Pythagorean theorem, just with some extras. So it is a squared is equal to b squared plus c squared minus 2bc cos a. You can manipulate it for whatever side line you are looking to find. So the letters can change. The law of cosines gets used for geometric scenarios of side, 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 and side angle side. Okay. So here is your one example. Again, I think you'll find it to be easy. It's just a long formula. So I'm going to say in triangle WXY, little y is equal to 3.6. Little w is equal to 6. Angle x, that's an angle symbol, is equal to 147 degrees. I'm going to put that there just so you see that. And find the length of little x. So you're going to begin by drawing your triangle. So we have W, X, Y. So W, X, and Y, where little y is 3.6. Little w is equivalent to 6. And angle X is 147 degrees. You guys see how this one's different? You don't have a double copy of like a W or a Y, so law of sines won't work here. So look at your geometric relationships. Do you have side, 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 side angle side? Which one do you have? Side angle side. Yep. So anytime you have this, again, this is going to lead you to law of cosines. You're going to start your formula with whatever letter we are looking to find. So we're looking to find x. So instead of starting at a squared equals, I start at x squared equals. And then I'm going to go either y squared or w first, it doesn't matter. So how about y squared plus w squared minus 2 times y times w times the cosine of whatever letters on the left-hand side, which was x. All you do is sub in. So I have x squared equal to 3.6 squared plus 6 squared minus 2 times 3.6 times 6 times cos of 147. If you look at the entire right-hand side of that formula, is anything unknown? No. So all you do is put the entire thing into your calculator. Very carefully, please. And do not round this decimal. You got to write the whole thing out and do one more step with it. So x squared is going to be equal to something. So in your calculator, I got like 85. Okay. So 85 point. And again, you don't have to write this on the paper, on your paper, if you want to just keep using your calculator instead. And how do I get rid of a square? Square root. So you're immediately going to just square root this answer. So x is equal to the square root of all of that. So therefore, x is equal to, what'd you guys get? 9.2. Perfect. And then you're done. So that is how we use law of cosines. Would you agree it's not bad? Yep, so law of cosines is sine, angle, sine, or sine, sine, sine. We'll do more with that tomorrow, but I just wanted to give you at least one of those for comparison purposes. Your homework. I want you to start it tonight. It's not due until Wednesday morning. It is some application problems on Delta Math. So you're going to have to do some law of sines, some ambiguous case, and some law of cosines. You've got a couple minutes to get those started, but I'm not checking them. So Wednesday morning.